So in the last video, we talked about the blood identification method, and we said there's a very common method that we have really always used indicator-wise throughout the course of the program, and this is PHTH or phenolphthalein. So phenolphthalein, we said we put a few drops onto a suspected blood sample, and a little bit of peroxide maybe after the fact. And if that is blood, then phenolphthalein will make my Q-tip turn pink. And this is what we see. So negative test, completely clear, no color associated at all. And then if it is blood, it will turn pink on the end of your Q-tip, and that's all due to the phenolphthalein indicator. And we talked about how that works. So we called this the Kastle Meyer test, and the Kastle Meyer test is a very easy test that I can use in a laboratory to make some observations and record some things that I see to help prove that something is blood. All right? There's a couple of other methods, though, along the course of the way that have gotten a little bit better than the Kastle Meyer test, and one of them is using this thing called a HemaStix. HemaStix basically take this concept of blood identification, and it will do something very similar. Basically what happens is that this is a strip that is ready to go. So it's very convenient. There's hardly any prep work involved at all. The only thing I have to do is grab a stick out of the jar and away I go with it. The drawback is that these things are very expensive, okay? So it really depends on your lab. If you do blood test and you want to quantify something or make some observations and qualitate a blood sample, this is an option for you. The HemaStix, how does it work? Well, it doesn't work by phenolphthalein. Here's the structure that you're seeing on the screen right now. And this structure is called tetramethylbenzidine, TMB, okay? So tetra, for those of you in organic, tetra means 4. So 4 what? 4 methyl groups, right? That's tetramethyl. Where are those 4 methyl groups? Well, there's one here, and there's one here, and there's one there, and there's one here. Okay, so there's the tetramethyl. And notice that these are on 2 what we would call benzene rings, okay? This is a 6-membered ring like a cyclohexane, but it's not an ane, it's an ene because there's a double bond in there. And there's multiple double bonds, and it alternates. It's a conjugated system. So double, single, double, single, double, single. And those 2 rings are benzene, and they are connected together. So that's where you see this word benz come from. It comes from the word benzene. The INE ending at the end here, that INE ending's very common with amines because, look, they end in INEs as well. So these enes are NH2 groups typically, and we do see NH2 groups on the molecule. We see one here to the left, and we see one there to the right. Okay, so tetramethylbenzidine, TMB. So basically what happens is that you do something similar like you did with the Kastle Meyer test. You swab the area with a cotton swab, just like before. Then you place that onto the HemaStix. So the HemaStix you're seeing down here at the very bottom of your screen. And if hemoglobin is present, which is a very good sign that the sample is blood, the hemoglobin will make this strip turn green or blue-green color from what it was, okay? So I've got this YouTube link down here. If you want to copy and paste that, you can. That's going to be very hard, though, on your screen. You would have to type it out. But this YouTube video is actually going to be embedded into the Blackboard system. So this is one of those external videos that I would like for you to watch on how they process something like a HemaStix to identify if a sample is blood. Again, it's very quick, it's very easy, there's no extra reagents that are needed. You literally swab the area and you place it on the HemaStix and it takes care of it for you from that point on. But the drawback, again, they're very expensive. We also have this thing called Hematrace. Hematrace is very common to the HemaStix. They're very similar in structure. They're very similar as far as the methodology goes. But again, this is a blood identification test that can be done on a different way. Notice that on the screen, though, the good thing about this one is that it's not a presumptive test. if it shows up positive with the HemaTrace, then we can pretty much say that this is a blood sample, right? There's other things that could make this molecule react and turn blue-green, not just blood. And on our Kastle Meyer test, there's also things that could make phenolphthalein turn pink, not just blood. But with the HemaTrace, this is a little different. The HemaTrace will actually use what we would call a chromogen, CHROMAGN, a chromogen, and some antibodies, very similar to how our blood typing was done, right? So if you remember, we had this discussion about antibodies and antigens and our red blood cells making antibodies that will go out and attack the invaders that come in. Those things have to be very, very specific. So the HemaTrace has taken kind of this concept of the antibody, and it has said, okay, let's kind of improve the blood identification test, and let's make something that will sure enough tell us if something is blood or not. So that's basically what happens here. So this antibody and the antigen reaction that goes forward in the HemaTrace test, that is a almost 100% sign that it is true enough a blood sample. This test works very similar to a pregnancy test. So what you're seeing on your screen right now is the HemaTrace, and this S area, you can kind of see that stamped onto the slides. That S is the area that you would put your sample in. So your sample typically will be swabbed, it will be put into a buffer, and a drop of this or the Q-tip would be basically applied to that area. And this would start sucking up that liquid. What you're seeing here on the bottom, this is a negative test. Again, it's very similar to a pregnancy test that you would do maybe at home. And the sample will be sucked up, and slowly, 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 it will go up this absorbent. And then here at the very end, we have a control band. That control band has to show up. That is a very good sign that this has taken my sample, and the sample has basically made its way up to the end of this absorbent pad. So this will always be a positive signal every single time. And we see that C that's stamped beside of that, and that C is for control. So I need to see the band that's present, right? That is a sign that my test has worked the proper way. Here below the T or C, you're going to see a T that's stamped into the plate, and that T is basically your test, okay? That is the test strip, and you're looking for the presence of that band. And if the presence of that band is there, like it is here in the top one, then that is a positive read. That means the sample that I have tested is, sure enough, a blood sample. Here I do not see that band beside of the T, so that is a very good sign that that sample was not blood that I tested. And that's really all that the HemaTrace is. It's a very simple test. It's a very quick test. If you can do a pregnancy test at home, you can do these tests without a problem at all. All right. So again, you're going to see a few of these external videos of people using the HemaTrace, and they're going to show you how they go through swabbing a sample, putting it into the buffer or the solution, and then applying that solution to the HemaTrace strips. I'm going to call these strips even though they're not really a strip. Okay. All right, so that's all that I really want to talk about in this video. 2 more ways that we can identify a blood sample. And then in the next video, we're going to talk about our third way, and that's not really using reagents at all, right? All of these we've used reagents with. We've used phenolphthalein, and then in the HemaStix, we've used this TMB reagent, and then in the HemaTrace, we've used the actual specific antibodies and antigens that can be found on the surface of a red blood cell and hemoglobin in order to do the test. So it's getting more and more and more specific as I've kind of went through the PowerPoint slides here. So in the next one, we're not going to talk about any reagents at all, but it's going to be another very quick way that we can go through and figure out if something is a blood sample and actually see where blood stains or body fluid stains might be without using just the naked eyeball that I have on my head. So come back The next video, that's where we'll pick up.